Names and formulas for, hey, what do you call it when you have a compound made of two nonmetals? Molecular.
You sure did. That'll work.
Okay, so names and formulas for molecular compounds. The first thing I'm going to tell you is that molecular compounds do not form these nice simple ratio of compounds like the ones that we just did, the ionic ones. They instead follow some very different rules that are very complex. Some of those rules we may get to this semester, the more simple of them. It just kind of depends on how the timing of the curriculum in the school year winds up. That's something we do toward the end of the year, if there's time. However, it is very easy to learn how to connect a formula to the name of those compounds. And so you all have in your hands there a stick, a couple of sticks to choose how to make a compound here. And we're going to do it in a way that you may or may not actually make a real compound. But in any case, whether it's a real compound or not, we'll look it up and see, because that might be fun. You can follow the rules to name it, because the rules for naming these are very straightforward. Okay? So the first thing is that, of course, this is made of two, technically, or more, but we won't do ones with more. Okay? Nonmetals. Okay? And the way that you do it is that you take the first one. So let's see here. I don't have any. I'm just going to pick two because I don't have sticks in front of me here. So I'm just going to pretend I'm making one out of nitrogen and oxygen. Okay? And so what you're going to do is you're going to take the first one and you're going to write it, and you're going to take the second one and end it with I, just the same as we've been doing, but there's a difference. You have to add prefixes to each word, indicating how many of the atom. And I'll give you the prefixes here in a second. Yeah, it's those. So the important thing here to realize is that a lot of the nonmetals can form different numbers of compounds. Chris, put your mask on. So like you could have a compound that has, for example, have you heard of carbon dioxide?
Yeah.
1 carbon, and how many oxygens is that? 2, right? Have you also heard of the compound called carbon monoxide?
Yeah.
That's 1 oxygen. So you see what I mean? They don't just follow these nice simple rules like the metal non-metal ones do. They can combine in different ways. Okay? So here are the prefixes that you need. 1, we use mono. 2 is di. 3 is tri. 4 is tetra. And of course, these are all prefixes there. 5 is penta. 6 is hexa. 7 is hepta. 8 is octa. 9 is nona. And 10 is deca. So, I want to stop you from writing there. I want you to have time to write. Make sure you get these down correctly because they'll be super important. What's up, Leah?
Do you also use these if you're combining metalloids?
So when metalloids are involved in a compound, there are some complicated reasons for why it may or may not do this, or it might do the other thing. Like it might do the ionic thing or the molecular thing. Don't trouble yourself with those.
Okay.
Don't worry, I won't ask you a test question that would mislead you to answer the wrong way.
Okay.
All right, you got it all written down? Can I go on? Let's just say that I want to make a compound out of 2 of each. 2 nitrogens and 2 oxygens. What would I do? Dinitrogen dioxide. Right, that would be N2O2. Make sense? Make another one. Make one up. Huh? You know what? Don't worry about which one to do first. It will never be set up in a way that you have to get a wrong answer because you chose wrong. If you have an oxygen, always make oxygen be last. We will only do the ones that have 2 in them. But I just wanted to put that in the definition. Technically, you could have more than 2, but we will only do the 2 ones.
What are the rules? Like, I know we're not going to do that, but is it just which one comes first? That makes sense.
All right. What about, can you make, I'm going to trick you. Are you ready? Can I trick you just a little tiny bit?
Okay.
Don't write this one down yet. Let me write that down. There's one little tiny quirk to this direction here. When the first one is a 1, you don't put it on. Does that make sense? So this is not nitrogen monoxide. This is just nitrogen monoxide.
Is that like carbon monoxide?
Just like carbon monoxide, yes.
Yeah.
But notice that I did put it on the second one, just not on the first one. Oh, this is supposed to be dioxide. Sorry about that. No, you should write that. I didn't want you to write it I didn't want you to write it wrong, so I told you to wait. What? This?
Yeah.
Yes. All right. All right. Who else made one? Did anybody make a funny one? Anybody make a crazy one? What'd you make, Julian? Dineon. What? Dinitride? Yeah, so that one, I'm going to tell you right now, that one would have to be Ne2N2. Yeah, probably not a real compound, but see what I mean? It just works just fine. What? Can the what? Usually not. Xenon does a certain amount of that, more than the other ones do. Usually they don't. But that's why I said, you can follow these rules. This is what it would be if it was a real compound. Yeah. Okay. So that's how you do it. Pretty straightforward, right? So ptable.com is the Wikipedia periodic table. So as you can imagine, then that means that it has a lot of information in it. It's also, do you recognize it? It looks just like the one that I printed off for you. Okay, it is. That's where I got the PDF to print this off. So what you can do is you can choose this where it says compounds up here at the top. And you drag your elements inside to create compounds. So like I could drag nitrogen and oxygen into there. And it will tell me over here all of the compounds that involve both nitrogen and oxygen. Okay? And so I could look here. You see how many of them there are? Of course, it's also adding other elements too at the bottom. But I can look here and I can see Oh, look. There's here. Oh my gosh. You guys know what this means? You remember doing this? When the 15 is up there in the front instead?
No. What? Oh, wait, it's not like the.
Starts with an I.
What?
It starts with an I.
I know. Yeah.
What? Not ions.
I know what it is.
It starts with an IS. Isotopes. So this is one that it's a specific isotope of nitrogen combining that way, okay? And then you've got a whole bunch of options down here. It looks like my mine were all real because I kind of knew that they were. Or no, my N2O2 was not real. I just made that up. But you can see. So get your Chromebook out and check your compound and see if you made a real one or not.